Okay, first of all, is it all set up right, or do I need to add any zeros? Good? Okay. Yeah, I got an x cubed, so there should be an x squared, which there is. There should be an x, yes, and a constant. But if something was missing after that x cubed, we should add 0, whatever's missing. Okay? Also on the outside, your last one had that x squared plus 1, I think. I would have put x squared plus 0x plus 1 on the outside, just so everything lines up when it goes in over here, when you do the multiplication part. Okay? So do that on the inside and the outside. All right, so anyway, this one, we always just concentrate on the first term divided by x. So every time I subtract and keep moving, it's the first term divided by that first term, which would be x in this problem. Okay, so 5x cubed divided by 1x is a 5x squared, and that goes up top here. Then I'm going to multiply 5x squared times the x and the 3. So I get 5x cubed, and then 5x squared times 3 is 15x squared. So everything's lined up. Subtract. These should always cancel. Those first terms should always cancel. All right, then it's 6 minus 15, which is negative 9x squared. And then again, we're going to drop the next term and just start over. So again, I'm just worried about the negative 9x squared divided by the x, which is negative 9x. That goes up here. And then I multiply or distribute negative 9x times x and negative 9x times 3. When I subtract, negative 9 minus a negative 9 is negative 9 plus 9. Negative 17 minus a negative 27 is negative 17 plus 27. That's a positive 10x there. And bring down to plus 20. Questions so far? We're good? So again, I go 10x divided by x. Again, it's just a monomial divided by a monomial when we actually do the division part. Okay? So those aren't really hard to do. So again, don't let all this other stuff behind mess with you. So it's just 10x divided by 1x, which is 10. And that goes up here, then 10 times x and 10 times 3. And then subtract, those go away, and 20 minus 30 is a negative 10. So that's my remainder. So when it's negative, I just put minus in front of my remainder. If you want to, again, make it always addition for your remainder, just make that numerator negative 10 on top there. Okay? We're good? Simple, right? Number 3, answer was x cubed plus 2x squared minus x plus 1, and then our remainder was 1 also. So plus 1 over x minus 2 for our remainder. Number 6 was, it wasn't in the right order when they gave it to us, so make sure you put it in the right order. You did not have to add any zeros. Oh, number 3, you should have added a 0x cubed for that first one. Okay, so number 6, put it in the right order. You didn't have to add any zeros. And you get x squared plus 5x plus 14. And then your remainder was 23. So plus 23 over x minus 2. Any questions on 3 or 6? Okay. Number 9, I wanted to go over with you guys. Make sure that seemed like the one that was giving people issues a little bit. Okay, that had a trinomial out front, right? 2x squared minus x plus 1. That's okay. And then we've got an x to the 4th third squared x and the constant. So I don't have to add anything. 2 2 plus 5 minus 6 plus 4 plus 2. Again, in the right signs. 2 plus 5 minus 6 plus 4 plus 2. Okay. So again, all I worry about is that 2x to the 4th divided by 2x squared. I don't worry about anything else, which is x squared. Okay, or 1x squared. Then I distribute this. So there'll be 3 terms under here because I'm multiplying by 3 terms here. So x squared times 2x squared is 2x to the 4th. X squared times negative x is negative 1, if you want to write the 1, x cubed. And x squared times 1 is x squared. So I just subtracted 3 terms instead of 2 like the other one. That's all. So the 2x to the 4th cancel. 5 minus a negative 1 is adding 1. Negative 6 minus 1 is negative 7. And then bring down the 4x. All right, and then divide. Again, just the 6x cubed divided by the 2x squared would be 3x. And then distribute the 3x. 3x times 2x squared. 3x times negative 1x is a negative 3x squared. And 3x times 1 is 3x. Those cancel. I've got a minus a negative 3 here, so that's negative 7 plus 3, which is negative 4. And 4 minus 3 is a 1. And then bring down the 3. So again, just this monomial, this first term, negative 4x squared divided by 2x is a negative 2. And multiply. Negative 2 times negative x is a positive 2x. And negative 2 times 1 is a negative 2. And then subtract, minus a negative makes it negative 4 plus 4. 1 minus 2 is a negative 1. And 3 minus a negative 2 is like 3 plus 2, so that's a 5. So that's my remainder this time. Can't go any further there. Okay, because you can't divide negative 1x by 2x squared, because x squared is bigger than x, right? So I just put that, since it's negative, 1x plus 5 over all of that. So, we didn't go over one like that yesterday, so I wanted to go through that today. I doubt if we'll see one on the quiz, though. It'll probably just be a binomial in here. And then number 12, you got the x to the 5th, 4th, 3rd, squared, x, and the constant, so you didn't have to add any zeros there, but what I would have done for 12 is I would have put it out front, x squared plus 0x plus 1. That would just keep everything lined up for you. You just get zeros whenever you multiply by that. But that answer is x cubed plus 3x squared minus 3x minus 10. And then the remainder was 2x plus 14. So it's plus 2x plus 14 over x squared plus 1. Does anybody need to see 12? Or are we okay? Okay, so long division takes a little bit longer, right? That's what it's called, long division, I guess. All right, but synthetic, what we're doing today, a lot quicker. Okay? So it's a shorthand method of dividing a polynomial by a linear binomial. So these will always be binomials. We won't have any trinomials like number 9 that we're dividing by. And all we're using is the coefficients. For synthetic division to work, though, the polynomial must be written in standard form using 0 and a coefficient for any missing terms. Using 0 as a coefficient, it should be, I think, not and. It should be using 0 as a coefficient for any missing term. And the divisor must be in the form x minus a. So it's going to be a binomial, x plus or minus some number. Okay? So here's a little example. we got 2x squared plus 7x plus 9 divided by x plus 2. Okay? So when you start, you write your coefficients, 2, 7, and 9 up there. And then we have this upper left corner, I call it the box, is whatever value of x makes that equal to 0. So basically it's the opposite of, that's a plus 2 there, so this would be negative 2. If this was x minus 2, then in our box would be a positive 2. Okay, so that's the one thing you got to remember there. You give yourself some room underneath these numbers because you're going to write some numbers under those. So I draw a line, and then what you do is you drop that first coefficient below the line. That's where that first 2 came from. You just drop it straight below. So, like in long division, we drop the back one. Here we're going to drop the front one. Okay? Also, we're always going to add instead of subtract like we did in long division. Okay? So that's the difference. We're going to drop the first term under the line, and this is always addition then. Now how we get this negative 4 here is we do multiplication. Negative 2 times 2 to get that number, negative 4. Then we add these, 7 plus negative 4. That's how that 3 comes about. And then we go negative 2 times 3, and that's where that negative 6 comes from. Put it under the 9. And then we add those. 9 plus negative 6 is 3. And that's our remainder. That last number is always our remainder. Okay, so there's the answer. 2x plus 3 over x plus 2. This variable here is always 1 less than the original. It started out as x squared. So in our answer, this first term will be 2x to the first. If that was x cubed, then that would have been 2x to the second to start. And then you just go down by 1s as you go. You guys remember that from last year? It's a lot quicker and easier. Any questions? All right, let's go through one together. Okay, so in my box, I got x plus 2 again, so I'm going to use negative 2. All right, so remember, it's what value makes that equal to 0, okay? And then I got an x to the 4th, an x cubed, so use the sign as well. That's sometimes we forget, that's minus 1 there. We're missing an x squared. Got to go in order, right? So I have to put a 0 in the next spot. Then the 5 for the x, and then the negative 1 for the constant. So that's how we would set it up to start. Then we got to give ourselves some room and draw that line. Yes, sir. Oh, really? Okay. I will try and get another one. I don't know. What about, I don't know. Want to try? Is Lewis? Yeah, try Montgomery or Louisville. Okay. Yeah. Yeah, that's true. Okay. Thanks. Okay, so you make your line, give yourself a little room. You're going to put a number above that line, right? You're going to drop that 3 below, start. Okay, remember it's going to be addition. So it's negative 2 times 3 to get this number. And then we add these, that's negative 7. Then it's negative 2 times negative 7, get positive 14, and then you add 0 plus 14. And then negative 2 times 14 is negative 28. And then 5 plus negative 28 is a negative 23. And negative 2 times negative 23 is a positive 46. And then negative 1 plus 46 is 45. Any questions on how I got the numbers? Did I make any mistakes? Sometimes I get in a hurry. I think I did it right. So then my original problem was 3x to the 4th. So my answer remember, is always one less for my exponent. So this starts as 3x to the third. And then this goes in order. Minus 7x squared plus 14x minus 23. And remember, that last number is my remainder. So it's a positive 45, so I'll put plus 45 over what we were dividing by, x plus 2. So synthetic division, much better for polynomials than long division. Right? Okay, you guys try this one on your own, please. Shouldn't take you long. Remember? Missed it. Messed up. Put your remainder over. Didn't say skip.
Yes.
We did two times. Yeah. Julie Bob. Didn't I call you that before?
What was Julie Bob?
I think it was.
Something different.
It was X plus, right? All right, you guys are doing good. So in our little box, we're going to use -3 because it was X plus 3. Then we got 6, -5, -6. Didn't have to add any zeros. Drop our 6 down. -3 times 6, -18. Add. -3 times -23, positive 69. Add. Remember, this started out as x squared, so this would be x. Okay? A different spin on this is this remainder theorem. It says you can use synthetic division to evaluate polynomials. It's called synthetic substitution. The process of synthetic substitution is exactly the same as the process of synthetic division, but the final answer is interpreted differently. Okay, so if I'm dividing this polynomial by x minus 3, I put my 3 in here in the box. I got my 1, -4, 5, and 1, and then I do my multiplication and addition. All I'm worried about when it's synthetic substitution is that if I were to substitute 3 in here, here, and here, and just evaluate it, just do that problem, the answer would be 7. So it's just a different way to evaluate a polynomial. It's just like substituting whatever's in the box in for x. But you don't have to. You can just do the synthetic division, and the remainder is the answer. You don't have to write all this out. Okay? If we were doing synthetic substitution here, the answer would just be 63. If I put -3 in there and there, I'm going to get 63. Okay? So in this problem, sometimes they write x, x minus 2 on these. A lot of times they'll just tell you what to make x. So you just put 2 in there because it says x equals 2. So don't do the opposite when it says x equals, when we're doing this synthetic substitution or the remainder theorem. All right, so again, I used my 2 for x cubed, my 5 for x squared, -1 for the x, and the 7. I didn't have to add any zeros. You still check for that. You might need to do the zero there. Just drop your 2, and everything else is the same. Drop your 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. -1 plus 18 is 17. 2 times 17 is 34. 7 plus 34 is 41. If I were to substitute 2 there, there, and there, I'd get 41. Okay? The other thing they're going to ask you is to see if, like they'll give you something like this, and they'll ask, is this a factor of that? If I were to try to factor x squared minus 5x minus 6, I get my 2 factors. All right, would x plus 3 be one of them? Okay? And the way you can check that is put in, the -3 here. If the remainder is 0, if you get a 0 there, then you would say, yes, it's a factor. So you have a couple problems that they'll ask you that. Is such and such a factor? If you get 0 for the remainder, you say yes. If you don't get 0 for the remainder, you say no. Okay? That's all. So everything else is the same. You do it as a normal synthetic division problem, and you're just looking at that remainder. If it's a 0, yes, it's a factor. If it's not 0, no, it's not. Okay? Okay, so here's, since I would put -1 in the corner, whatever I get for my remainder, that's the answer to something like that. All right, so there's your problem today. Good job, like always. Remember, we still got this week and next for the to finish off this second 9 weeks. There's a couple of you that still need to do your exam. All right, so we should be getting going on those tomorrow. You know who you are, Logan.
Are you gonna have a class after this?
No.
You go over some of the stuff.
But I don't have.
Yeah, I can do that now, too.
So what my kid, it's always messed up. Okay. Sorry.